let's work on this limit problem. And we're going to graph it as we go to understand this function. So I have a function f dependent upon x, and it's a piecewise function. It is going to look like this rational function when x is less than 3. It is going to look like this rational function for x values greater than 3. All right, so let's work on this first one. Number 1. The limit as x approaches -9 of the function. Now, when x is getting close to -9, it's certainly less than -3, or rather +3. So it's certainly less than +3. So I should look at the top function. This one right here, right? When x is less than 3, I listen to that guy. So x squared plus 3x minus 28 over x plus 7. And I want to look at this function as x gets close to -9. All right, so as always, I first directly substitute. Can I send x to -9? So if you do this, you find that you do actually get a real number. If you evaluate your function at -9, you return -13. So at -9, the function is down here at -13. All right, now let's work on number 2. The limit as x approaches -7. The limit as x approaches -7, what is the function doing? Well, at -7, I should again listen to the top function. X squared plus 3x minus 28 over x plus 7. All right, now if I try direct substitution here, I can right away see that I'm going to get a 0 in my denominator, and you'll see that you also get a 0 in your numerator. If you plug -7 in for these x values, 49 minus 21 minus 28 does give you 0. So we have 0 over 0. It's that indeterminate form. We need to try this again. Now note, this function might be able to be simplified. So let's try that. I have x plus 7 in my denominator. It's as simple as it can get. But the x squared, the quadratic in the numerator, can factor as x plus 7 and x minus 4. Now, if you don't believe me, pause it and perform this multiplication and make sure that you get this numerator. Now, by doing this, I can see that I have some cancellation. So really, this function is no more complicated than the function x minus 4, just a straight line with a y-intercept of 4, a slope of 1. The only difference is this function exists when x is equal to -7. This function does not exist because you would divide by 0. But they're equal everywhere else, which means we can use it in the limit. Via direct substitution, -7 minus 4 gives us -11. So as x gets close to the value -7, our function obtains a value of -11, or rather, it gets close to the value of -11, but it never actually fills in that circle. All right, and like we said, this function continues as a straight line with y-intercept -4 all the way up until -3. So let's do that. Poor art skills, I'm supposed to cross at -4, and that's supposed to be a straight line. And I listen to it all the way up until +3 with an open circle. Now that we've done number 1 and number 2, let's do number 3. Find the limit as x goes to 3. So exactly where does that open circle happen at? What y value is that open circle at? So the limit as x approaches 3 of the function. So note, by our definition, I'm this function on the left of 3. I'm this function on the right of 3. So therefore, these functions might do different things on either side of 3. It would behoove me to I think I said that wrong. It would be in my interest to look at the left limit as x goes to 3 and the right limit. So let's approach 3 from the left first. Now, as long as I'm on the left side of 3, I should again listen to the top function. Which is equivalent to the function x minus 4 at all points except at minus 7, which we don't care about because we're getting close to 3 from the left. This is 3 minus 4 minus 1. So the way that we do the picture is correct. That open circle right there occurs at a y value of minus 1. Let's look at the limit of the function as x approaches 3 from the right. Oh, there we go. So as x is larger than 3, I should listen to this bottom function. So my function is equal to x minus 14 divided by the square root of 2x minus 3 minus 5. And I want to look at this function as x gets close to 3 from the right. So I directly substitute. X is now 3. That gives me minus 11 over 6 minus 3 is 3 minus 5. Now, this is a nasty number because who knows what the square root of 3 is. But if you approximate this, it is about 3.366. So on the right side of 3, my function is getting close to 3.366. In fact, we were able to directly substitute 3 into this function, which means the function does indeed exist there. Right? I do listen to this function at x is equal to 3. All right, but notice what that means about the limit as x goes to 3. If I approach 3.366 from the right and minus 1 from the left, then I get two different real numbers for my limit. The limit does not exist. Right. This answer is not equal to that answer. All right, number 4. We want to look at the limit as x approaches 14 of the function. Now, when x is approaching 14, x is certainly larger than 3, which means that I listen to this second function again, x minus 14 over 2x minus 3 minus 5. All right, so with direct substitution, it's obvious that I'm going to get a 0 in my numerator. And if I plug x is equal to 14 right there, I get a 28 minus a 3 returns a 25. Square root 25 gives me a 5. 5 minus 5 is 0. I get that 0 over 0 form. So we try again. Limit as x goes to 14 of x minus 14 over square root 2x minus 3 minus 5. Now I can multiply this function by 1, thus not changing it. And I'll multiply by 2x minus 3 underneath the square root, now plus 5. Now, if this is going to be equal to 1, it has to be same thing, top and bottom. And this is multiplying by the conjugate. So I'm going to leave my numerator alone, x minus 14 multiplied by 2x minus 3 square root plus 5. But my denominator is going to simplify quite nicely. When the square root 2x minus 3, oops, I made a mistake. This should be 2x minus 3. When the square root 2x minus 3 hits the square root 2x minus 3, it returns a 2x minus 3. When the square root 2x minus 3 hits the plus 5, I have plus 5 square root 2x minus 3, but then it's immediately taken away. And finally, minus 5 times the plus 5 returns a minus 25. My numerator will stay the same, but there's simplification in our denominator. Two x minus 3 minus 25 gives us 2x plus, oh, no, not plus, be 2x minus 28. Which, how can we do with this? We can write this. Let's copy our numerator down. But our denominator, we can pull out a 2. And there we see the x minus 14 that we were looking for. So now we just have square root 2x minus 3 plus 5 sitting on top of a 2. Let's try directly substituting now. Two times 14 is 28, minus 3 is 25, square root 25 is 5. All of that just for 5. So the function, as we get close to 14, where's 14? Right there. X is equal to 14 there. It's close to the y value of 5. Right, and we listen to that function for infinity.